This screencast is on scientific notation from the Unit 1 Part 4 note packet. So scientific notation is something that you've seen in the past, but this is used when numbers are really, really big or maybe really, really small. So one thing I want to point out is that for scientific notation, we're going to have n, which is our number, times 10 to some nth power. This n here has to be in between 1 and 10, but it can't be exactly 10. It has to be a single digit. And then we're going to have some kind of exponent here, and this can be a negative or it can be a positive. So we're going to take a look at some examples. So here we have 2.08 times 10 to the fourth power. So 2.08, if we wanted to write it out, because this power is positive 4, we're going to go 1, 2, 3, 4 spaces to the right. And that's where they're getting this number, 20,800. So same thing with our 2.08 times 10 to the third power. So we will move the decimal point 1, 2, 3 spaces, and that's how we're getting 2,080. Again, if we take a look at 2.08 times 10 to the second power, that's 1, 2 spaces, and that's where we're getting 208. And then, of course, for the last one, it's moving 1, so one spot will give us the 20.8. So if you have scientific notation and this number here is a positive number, you're going to move the arrow to the right. Here's an example where we have a very large number and we want to write it in scientific notation. So first thing we want to do is locate where the decimal point is. If we don't see one, it's at the very end. So we want to move the decimal point so it's in between the 6 and the 5. So we have 1, 2, 3, 4, 5, 6, 7, 8 spaces. So our number is going to be 6.53937. We're going to drop the rest of the zeros times 10 to the 8th power. Now I know what you're thinking. You just said we have to move right when the number is positive, but in this format we're writing it in scientific notation, so we're taking a really large number, and that's why this is going to be a positive. So when you take a look at the examples down below, when we have small numbers, we are going to move the decimal point the other direction. So again, if you take a look, we have 2.08 times 10 to the negative 1 power. So we're going to move one spot to the left, and that's where we get 0.208. With 2.08 times 10 to the negative 2, we go 1, 2 spots, and that's where we're getting this answer. And then so on and so forth. If we take a look at number 2, we want to take this really small number and write it in scientific notation. So we want to put that decimal point in between our 5 and our 3, because we want one number in between 1 and 10, but not including 10, to be that first number. So we're going to go 1, 2, 3, 4 spots. So we have 5.39 times 10 now to the negative 4th power. Since we have a very small number, that's why that exponent is going to stay a negative. So the rest of these examples here, we're going to write it out. So we have 3.102 times 10 squared. Since that's a positive 2, we're going to go 2 spots. So we have 310.2. Okay, so we already did that problem, so I'm going to cross that out. So if we take a look at problem B, we have 7.4 times 10 to the 4th. So one thing you want to do is go 4 spaces. Do not add 4 zeros. So 1, 2, 3, 4. So we're actually adding 3 zeros, but moving the decimal 4 spaces. So a common mistake is to add that number of zeros, which is not true. Now for letter C, we're going to go negative 3. So we're going to go 1, 2, 3 to the left. So we have 0.00175. For D, 2.9 times 10 to the 5th, so 1, 2, 3, 4, 5. So again, we're not just adding 5 zeros, we're going 5 places. So we have our number. And then the last one, oops. So we're going to have our 9.99, and we're going to go 9 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm running out of space here. So we're going to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Or 9, 9, 9. For the last couple of examples, we're going to write it in scientific notation. So now this is where we're going to identify the decimal point. If we don't see one, it's at the end. And then we want to move it so that there's one number in front of the decimal point. So we're going to go 1, 2, 3, 4, 5 spots. So we have 1.2 times 10 to the 5th power. So we're going to drop the rest of the zeros. And it's a positive 5 because it is a larger number. Number 2, again, identify that decimal point. 1, 2, 3, 4, 5, 6 spots. So 1.765244 times 10 to the 6th power. So for the last couple problems, we're going to keep doing the same thing. So we have 63. So I'm going to put my point at the end of the number. So we're going to go 1 spot. So 6.3 times 10 to the 1st power. Number 4, again, I'm going to go 1, 2, 3 spots. 9.654 times 10 to the 3rd. 1, 2, 3, 4, 5, 6, 7, 8. So 6.53937. I'm going to drop the rest of the zeros times 10 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 point, all these zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then a 6. Times 10. Now I just lost my train of thought. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the assignment is to work on the IXL with our scientific notation.